The first conic section we're going to look at is a circle. You're very familiar with that. Now, why do we call a circle a conic section? Because if I take a cone, conic, and I do any sort of slice that goes straight through the cone parallel to the circle base, what shape I end up with when I cut through the cone is a circle. So that's why a circle is a conic section. So for my formula, I have x minus h squared plus y minus k squared equals r squared is my, we'll call it conic form of a circle. So my center is h, k. Remember in math formulas, minus just means opposite. Opposite. And then my radius is r. So say I have the equation x minus 4 squared plus y plus 7 squared equals 9. Then my center would be the point positive 4, negative 7, and my radius would be the square root of 9, which is 3. My most basic circle is one that's centered at origin, at 0, 0. And when I add 0 to x or to y, I'm just left with either x or y. So my super simple circle equation is x squared plus y squared equals r squared, and my radius is still r. But of course it needs to get a little bit more complicated than that. So what this is I don't have my whole parentheses squared plus parentheses squared equals something. My goal is to make it look like that. So way back last semester when we did completing the square for vertex form, now we're going to do completing the square to get to our conic form of various types of conic sections. So our first step, though, since I have x's and y's going on, is to get my x's together and to get my y's together. So I'm going to just move everything so they're right beside each other. And some of you are going to be able to move to where you can do this, some of these steps in your head without using the box, and that's totally fine. That's awesome. I'm just going to show you using the box though. So we want to get our x's and y's together, and then we're going to move our constant. So I'm going to be lazy and just erase this and say equals negative 11. Because I usually do that in one step. So get x and y's together and then move your constant to the other side. Now what I'm going to do is think of this as kind of two different problems. So we're going to complete the square with what I have for x's and complete the square with what I have for y's. So first term, first box, and when we complete the square, we're splitting our linear term, which is this one with x, in half. So minus 4x, minus 4x. So I have x, x, minus 4, minus 4. So that gives me x minus 4 squared. But what do I have here? Gaping hole, which is 16. And if I add that on the left, I need to add it on the right. And now we're going to do the same thing with y. So y squared, split it in half, 2y, 2y, y, 2, 2. So plus y plus 2 squared. Gaping hole is 4, so we need to add 4 to the other side. And then we add up all of this, and we're going to get 9. So my center would be 4, negative 2, with a radius of square root of 9, which is 3. So if I want to graph a circle, then we're going to plot the point that's our center. So 4, negative 2. And then right, left, up, down, I'm going to go 3 units from my center. So right 3 from my center, back to center, left 3 from my center, back to center, up 3, and down 3. We want to connect this so it looks like a circle. It shouldn't look like a square because we're drawing a circle. You think this is obvious, but it's not. All right, so let's look at this next one. First thing I want to do is get my x's together and my y's together. So 3x squared plus 12x plus 3y squared minus 6y equals, move the 9, -9. Now, as I'm writing that, what is something you notice? I notice that everything is divisible by 3. In these problems, when everything is divisible by the same thing, we're going to go ahead and divide that out. But this is if and only if everything divides by the same number. Not two things, all the things. So I get x squared plus 4x plus y squared minus 2y equals -3. Now I'm going to split up my problem. So on the left side, I'm going to do x squared, split 4x in half, I get 2x. Factor it out. X, 2, 2. So I get x plus 2 squared, but gaping hole has a 4. So I'm going to add 4 to both sides. Now I repeat the same process, focusing on y. Y squared, split -2y in half, and I get -y, -y. Factor it out. So I get y minus 1 squared. And my whole there is going to be 1. And -3 plus 4 is 1, plus 1 is 2. So my center is -2, positive 1. And my radius is square root of 2, which usually I want to leave, but we can approximate that as about 1.4 for when I'm graphing. So kind of sort of 1.5. So for my graph, I need to start at my center, which is -2, 1. And then I'm going to go about 1.5 units out, which, you know, me doing on this screen is really going to turn out well. But we're going to go with it. Approximately. No one is going to come hunt you down because your circle was not beautiful. Unless it looks like a diamond. Okay. So now we need to go backwards, which is where I give the equation, or I give you information and you write an equation. So remember, my general form is x minus h squared plus y minus k squared equals my radius squared. So for this first one, I gave you all the information. I have x squared plus y equals my radius squared. So I have x, remember with h and k, it's opposite. So plus 3 minus 4, and then we're going to do 5 squared. Of course, you can do that in your head. And we'll leave it as x plus 3 squared plus y minus 4 squared equals 25. What's different with the next one? I give you diameter. Well, the first thing I would do is if diameter is 12, that means my radius is 6. And doing the same process, we have blah, blah, blah. I have my h and my k, so plus 2 minus 6 equals 6 squared, which would be 36. So far, so good, hopefully. This last one is as hard as circles get, which says the endpoints of the diameter are blah and blah. Okay, I don't really want to graph something that goes out as far as 21. Do you want to graph something that goes that far out? Probably not. Could you? Yes. So what we need to remember is that the center of the circle is the midpoint of any diameter of that circle. So what I want to do first here is find my midpoint. So there's a formula, x1 plus x2 over 2, y1 plus y2 over 2. So let's just use that. It really is just averaging the x's, averaging the y's. So let's look at the x's. I'll be doing -1 plus -13 over 2, and then 7 plus 21 over 2. So -14 over 2, 28 over 2. So I get that my center is -7, 14. And then what we need to do is find the distance, which once again you could graph at this point and do Pythagorean theorem to find the radius, or we can use the distance formula. I'm going to do distance formula since that's what you're probably more likely to see later. So first we had midpoint. Then we also have distance, which is really just a fancy Pythagorean theorem. And if this was Algebra 1, we would just do Pythagorean theorem. But my distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so we want to be now using our center. And one of the points, I'm going to use the first point just because it's smaller numbers. So I have -7 minus -1 and 14 minus 7. So square root of -6 squared plus, that was so sloppy, y'all, sorry, 7 squared. So my distance, or basically my radius, is the square root of 36 plus 42, which is 78. So for my final formula, we're going to be using, this is my radius, this is my h and k. So x plus 7 squared plus y minus 14 squared equals my radius squared, and when I square my radius, I'm just going to get 78 because squaring a square root means the square root goes away.